Hi, welcome back to our channel. Back to the tutorial for deep learning. Today I will discuss the basics of ResNet 152. That is deep residual learning. What is ResNet 152 and why you need and what is the architecture of ResNet 152 and how we can place for the medical application like kidney recommendation for further analysis and find the disease also and advantages or merits and some various applications of ResNet 152 also. Introduction. ResNet generally construct a residual network and followed by a recurrent connections also. And moreover, these are developed by Microsoft Research in the year of 2015 and where enables very deep CNN training also. And the motto of ResNet is always reduce the gradient, vanishing gradient issue also. Solve that is OU ResNet means solve the vanishing, that is reduce the vanishing gradient issue and always use a skip connections where connect encoder and decoder for get the fine-grained information from the given city, given images. And it follow the formula for residual function that is h of x equal to f of x plus x. And moreover, the ResNet allows multiple times, that is allow the convolutions of the multiple times for better use and get the results also. There are ResNet family, there are ResNets like 18, 34, 50, 101, 152, sir. Osmos layers increases, Osmos deep learning trained well and give the best and better performance. And this is the ResNet 152 architecture where we have taken KTS 19 as input and what I'm going to summarize the points and the usage here. Here the input image size is that is 224 by 24 taken and then convolution operation performed that is 7 by 7 convolution for extract the over features such as edges and textures. Then max pooling operation that this performed for reduce image size and also preserve the important information. Then residual blocks like by 3, residual block 8 and residual block 36. Again residual block 3 is there. These blocks are used to learn complex features using the skip connections here. Then average pooling is there. The role of average pooling is convert the feature map into a compact feature vector. Then fully connected layers there. These are used for these are combined extracted features for further classification. Then softmax here. The role of softmax layer is compute the probability for each class. Then prediction is the end. The prediction layer, what is the final output? That is whether the given image consists of a normal cyst or a tumor like that. So the overall and simple architecture for better understanding of the ResNet 152 architecture. And then summary here. And OIV and some of the merits of this ResNet trees supports and give high accuracy and support better future extraction and future learning also, teach learning also, and always gives stable training for the networks, deep learning networks, and supports the transfer learning. Here, transfer learning means it's one of the deep learning technique in which a pre-trained model is reused for new task instead of training a model from the scratch. Moreover, this reduces the training time as well as improve the performance automatically, even if the available data set is so small. So applications, we can use the ResNet for medical applications, especially for identify the kidney CT diseases, lesion detection, object detection, face recognition, and etc. Then if you consider the medical imaging applications where you can take the CT images input and you can pre-process it done by for pre-processing you can use any type of filter, then you can utilize the ResNet for further classification and you can extract the feature and classify it. A class give the result like normal cyst or like that, tumor and etc. Then so what can conclude here? So ResNet 152 is one of the powerful deep CNN and where consists of a residual learning, this eases automations easily. And these are widely used for research also. And give the robustness and always prove the robustness and the accuracy and where increase the segmentation accuracy. Later you can implement the ResNet along with loss functions for better segmentation accuracy and improve the quality of the image also. Thank you for watching the video. If you like the video, please subscribe, share with your friends. Thank you.